This is a brief summary of the brake test pipeline. So from the Terminal 1, the simulation is launched. This is a custom world that was created, a simple brake corridor for the robot to travel in and perform the brake test. The assumption is that this world has already been, or this map has already been generated as a test scenario. However, this assumption can be bypassed by creating the map if desired. So we can go ahead and localize within this map by calling the raw service call, at which case we'll initiate the AMCL particle filter. For here, we can go ahead and launch the automized test procedure script, ROS run arrival challenge brake test, which will launch the automated brake test procedure. The first step will be to initiate a motion path for the robot to complete in order to localize. So we're playing back at 4x speed right now, but essentially the robot is proceeding to complete a motion pattern in which to allow the AMCL particle filter to converge. And again, all this testing and estimates of brake distance is done with onboard sensing only. So the AMCL particle filter has now converged, at which time we can clear the erroneous base maps with the raw service call, and now we can begin performing our tests. So again, this is all done via keyboard commands, so we can initiate a test by tapping the S key, at which point you'll be prompted for user entry into exactly what velocity you would like to perform the brake test at. So enter desired velocity. Desired velocity is entered. The robot will begin to go towards that velocity. When you want to brake, hit the space bar and then hit the R key to report. And in this case here, a stopping distance of 50 centimeters from a velocity of around 1 meters per second was achieved. Another test is now performed by tapping S, a desired velocity of 0.8 meters per second. Click enter and then stop the robot with the space bar and hit R for the report. So a stopping distance of 43 centimeters at a velocity of around 0.82 meters per second. And if we want to continue performing tests, we could reorient the robot with the arrow keys at 90-degree increments. So reorienting the robot so it can move down the corridor. And again, hitting S will prompt the user for input on the desired velocity. In this case, we'll enter 0.7 meters per second. Click enter and allow the robot to move at that desired velocity and report the stopping distance.